Here's one more lecture for Chapter 4. I'll be covering one more sample problem and reviewing equilibrium. As mentioned before, equilibrium is when the net force on an object is zero. This means that the object is not accelerating. In situations B and D, there is not a net force of zero on the object, and therefore the object is accelerating. Most of the examples that we will look at will deal with things in non-equilibrium situations. You will need to either calculate the acceleration and the net force or some other aspect of it for the problems that we will deal with. For situations when equilibrium does not occur, we need to find the net force. This is going to be the same as before when we were looking at velocity, finding the net velocity or total velocity with components in either direction. Here we have a component in the x direction and a component in the y direction. Right now, take a moment to calculate out the net force. I'll display the answer in a second. The important thing when calculating the net force in the x direction and the net force in the y direction is to add up all the forces and pay attention to direction. Paying attention to the direction that the forces are acting is extremely important. In this problem, we have a truck accelerating up a hill, and we want to find the maximum acceleration that truck can have before the crate starts sliding backwards. Since it's stationary to begin with, we're only going to be concerned with the coefficient for static friction. This is going to be our maximum static friction force that we're going to try and actually find before the crate starts sliding backwards. Remember to follow the steps as outlined in the next slide to make sure to be able to solve this problem. Remember, these are the steps that we want to follow when applying Newton's laws to any situation. Make sure to go through each step in order and set it up according to our problem. In this case, the truck accelerating up a ramp. First, what is our system? The crate, in this case, is going to be the only thing we're concerned with. Now, we need to draw a free body diagram for it. We have our weight directed downward, the normal force directed upward from the truck. So this is going to be a little bit different, at a slightly different angle than the weight. And then we have the maximum frictional static force is going to be directed up the hill. Now, time to choose our convenient axis. This will probably be, for most situations, along whatever motion that the object is taking. So in here, we're going to have the x-axis along the frictional static force direction and the y-axis going along the normal force because they're perpendicular to each other. Separating the weight out into its components, we have our sine and cosine parts of that. Next, we need to ask, is the object accelerating? It's not in equilibrium, so yes, there is a net force on it, so yes, it is accelerating. And finally, we need to set up our variables in a table to get a proper equation and solve. Now that we have our free body diagram drawn up, our axes all aligned, and we have the components for the weight, we can solve for what actually is the acceleration. To do so, we need to find the sum of the forces in the x direction and the sum of the forces in the y direction. We know that it's accelerating in the x direction, and we know that in the y direction, it's going to be in equilibrium. So the forces will balance out. Take a moment now and look at all the forces in the x and y direction and add them up. From this, you should be able to come up with some equation, filling in certain things and solving for other things. You don't need any numbers for this, to replace in different parts of the formula from maybe the y direction into the x component to be able to solve for the maximum acceleration that the truck can have. Do this in your notebook tonight and come into class tomorrow with any questions. Thank you very much.